All right, so we're going over this problem 2.71, or the dog one, as we called it. The dog runs back and forth between its owners who are walking towards each other. Showing the figure. The dog starts running, owners are 10 meters apart. Okay, the dog runs at this, and the owners each walk at the speed of this. How far will the dog travel when the owners meet? All right, so we want to think about when I think about the y here. 2.71. So when I think about the y, I think about what it means to meet, and I'm looking at this, and they're moving at the same speed, but opposite velocity. So I might note that. Let's see. They move with same speed, but opposite velocities. And I'm thinking that leads, because they move at the same speed, therefore they meet in the middle. They meet in the middle. That's kind of unique to this problem, right? Because if they weren't moving with the exact same speed, and they weren't moving towards each other with opposite velocities, they wouldn't meet in the middle. Yes? And then they're asking about how far the dog traveled when the owners meet. So, is that the dog's distance or displacement? How far he's traveled? Distance. So, that might be my next kind of main idea point here is, even right, we are interested in the dog's distance. During this time. All right, so it's going to, kind of this thing I didn't write in there, but during this time, it's going to take a certain amount of time for them to meet in the middle, right? Because it takes time to change where you are. So looking at the factors, I'm going to draw myself a little picture just to help me, but I'm only going to draw it halfway. I'm only going to draw this side of it, because my dog is running back and forth for a certain amount of time, and in that same time, the guy on the left has moved from what I'm going to call 0 meters to 5 meters. He's moving this way at 1.3 meters per second. So my instinct is to find out how much time it takes to meet the middle. And then if the dog moved continually for that amount of time, then I can say, oh, they moved for 2 hours, so he went this far. And not worry about how many laps it was. That's going to get really complicated, right? Because laps are going to get shorter and shorter and shorter as they get closer and closer. So I'm not going to worry about how many laps the dog does, but how long the dog has to move and where it is. So I don't think I have up our equation sheet. So let me pause for a second and grab that. All right, so I grabbed our equation sheet, and I'm looking at, okay, how long does it take for this person to walk from 0 meters to 5 meters? So I'm going to grab this equation, which talks about the other day, where I am based on where I started and how far I moved, because I was moving during that time. Right? That, make it a little bit smaller. So this person ends up at 5 meters, started at 0 meters. Now I'm not worried about the directionality, so I'm just doing it with where he is, not worrying about positive, negative, because everything's in one direction. Plus 1.3 meters per second, his speed, and delta t, the amount of time he moves for, which is the same amount of time as the other person moves for, and the same amount of time the dog has to move. So that delta t would end up being 5 divided by 1.3, which would give me, now I'm in the middle of the problem, so I want to keep all my sig figs. 3.8465 seconds. I'm keeping my sig figs. I'm going to keep it. That's the nice thing about the calculator, right? Just keep the number in there and then use it again. Otherwise, write down everything if you're like if you have a calculator that doesn't store well, like a phone. Now I'm interested in the dog. And so the dog is running back and forth at 3 meters per second and running for this amount of time. So I'm going to use my same equation. I'll just write it this time. D equals D naught plus V delta T. I'm going to just worry about how far it went. So I'm going to say, I want to know how far the dog went, so that's D. I want to know where they end up. They start at 0 meters, because I'm going to assume they started right there, right? They're moving at 3.0 meters per second for this amount of time. And I get an answer by doing that little bit of math. All right? So it's because the dog moved at that constant speed. Did the dog move at a constant velocity? No, but a constant speed. All right, so we're gonna, so this is number 10, also known as 2.115. So, 2.115. And we've got 2 objects. We know where one starts. We know, oh, actually, we know where both start. And they're moving towards each other. And they collide after a certain amount of time. So to collide, again, they have to be in the same location, right? So you might even put that. I'm going to put they end up in same location. Okay, so I think I need to draw a picture just to wrap my head around it. So we've got object number 1 starting here, and object number 2 starts at 13. So this is object number 2. Over here is 0. This is at 13, and this is at 25. And then it says object 1 moves with a velocity of negative 5.9. So they must be saying that this to the right here is positive. So number 1 moves backwards that way. Call that V sub 1. And then if 2 moves towards 1, which way does it move? Positively. So I'm expecting when they ask me here for the velocity here, there I'm make sure that I'm going to have a positive value, right? Now you guys have some different numbers for this, correct? Or are these your same numbers? Huh? You have this one open? So what do you have? Are your numbers 25, negative 5.9, and 13? And 0.6 seconds? Okay, so that's the number that's different. Okay. I wish they still getting used to this new site. Like in the site that I've used for years, that 0.6 would be in red to let you know that it was different for each person. So make sure you check because you will have randomized values in here. We want to find the velocity and the position of objects when they collide. So they end up at the same location. 2 is moving positively. And I might also mention that they have the same amount of time to move. Not only do they move to the same place, same location, but they have the exact same amount of time to move. It's not like one goes and then 2. They're moving for the same exact amount of time. That's probably enough for my y in that one. I'm going to grab my equation again. And let's we'll do number 1 in blue, and we'll do number 2 in red just to keep my outline of it. So dealing with number 1 right now. Number 1, where number 1 ends up, we'll call that location. Wherever they end up here together, we'll call that D. How about that? Number 1 started at 25 meters, positive 25 meters, excuse me, plus moved at negative, what was it? Negative 5.9 meters per second for some time t, delta t. Can I solve that equation? No, because I have 2 different variables, right? So no love there. Oh, wait a minute. I know t, don't I? They gave me t. They told me 0.6 seconds. So I do have enough. Hey, that's good news. So rather than delta t here, I have 0.6 seconds. And so I can solve for d. And I get 25 plus, let's see, negative 5.9 times 0.6. And I get in that amount of time, number 1 gets to the location of 21.46 meters, and that's a positive location. I know it's positive because I didn't get a negative answer. Now let's look at number 2, unless there's questions. Questions? Pretty straightforward. Pretty good. Okay. same equation, going to use the same equation, and I know that Q is going to end up at D also. Starts at positive 13 meters, plus, I don't know what B is, so we'll just call it V2, but I know it's positive, and it also moves for 0.6 seconds. Oh, wait a minute, I know D now, don't I? Yeah, I know D. 21.46 meters is where it ends up. So I rearrange all that. Probably should have checked that answer. I'm pretty confident though. I'll check it all afterwards. Let's see. So I would do 21.46 minus 13, enter, and then divide that by 0.6. And I end up with positive 14.1 meters per second. And I should check both these answers to make sure I got them correct. Let's see if I did. All right, we're moving on. Number 6. That is. So 2 cars travel on parallel. Let's see. 2 cars travel on parallel lanes of a 2-lane road. Okay. Wait a minute. Wouldn't that mean that they were going in opposite directions? Oh no, like 2 lanes, like like Route 1. Yeah, okay. I'm thinking like, never mind. And they're represented by this graph. Answer questions using the times from the graph indicated by the letters. So, at what time do the 2 cars pass each other? And then we'll see the other parts as we go. Okay. So, if we want to know when they pass each other, we may end up doing this Y kind of segmenting, right? What am I looking for on the graph? What do I mean? What has to be true to pass each other? Okay. What does that mean physically is going on? Excellent, excellent. So that is where they intersect. So number 6, we're looking, so pass when same place, location, at same time. And so, when's that going to be? Anybody? Anybody from the graph see? When are they at the same location at the same time? D. So we pick D and it's missed. Yay! And then 2 cars traveling in the same direction. What are the 2 cars traveling in the same direction when they pass each other? I hear a lot of no's. Why do you say no? One has a negative slope, and the other one has a positive slope. So the Y part of that would be that the slope is the velocity. So a positive slope is opposite in direction than a negative slope. I'm going to not click on that because I don't want, well, yeah. Good. And before you try to click it away. Good. Which which of the letter times, if any, does car number 1 momentarily stop? So what are we looking for on the graph to indicate stop? Right, so there's not that there's no slope, but there's, yeah. Well, that's the same as no slope, right? Yeah, same thing. Yeah, so we're looking for that slope of the position graph to be 0. So you might, I think we already took care of that in our while. At which of the letter times, if any, does car number 2 momentarily stop? Oh, number 1, does number 1 ever stop? No, it's got actually constant motion, right? It's car number 2 that actually we'll deal with in the next unit that has a changing motion. I actually went back and forth on whether or not to give you this one, but I decided to stretch you a little bit. So for C and D, we're looking at the slope, looking at 0 slope. Which of the letter times are the cars moving with nearly identical velocities? Again, we're looking for times that have nearly identical slopes. Which one? And I only see one time where both graphs seem to have the same slope. What do you guys see? A, I see A also. Yep. All right, good. So 7.1.2 about momentum. In my Y, I would start off with that my understanding of momentum. Momentum is inertia in motion. That's kind of the general saying, hey, I understand what momentum is. But then I also need to make sure that I'm specific to the problem. I'm going to say that due to less inertia, the ball must move faster than the bus. That looks like bus. So I'm expecting them to have the same inertia, same momentum. That means that ball has to move faster than the bus. I will grab my momentum equation. For my house side here. And the momentum of the bus. Now, today, let's see. So the bus moves at 11 meters per second, and it's 18,200 kilograms. So its momentum is 18,200 kilograms. I'm assuming that these are both moving in the same direction. So its velocity is 11.0 meters per second. And I'll get an answer of 18,200 times 11. I get 200 kilogram meters per second. Remember, guys, if I lose you at any point, say something and we'll back up. And then now I'm going to look at the ball. Momentum of the ball is, 200. And it's inertia 0.142 kilograms. Oh, good, kilogram. I don't even have to mess the units. 0.142 kilograms. 1 V of the ball. Right? And then mathematically, did some of that wonderment. Oh, look, I have my numbers short. All I did is divide. Oh, that should be a plus. Sorry. Oh, no, that's an equal. That's an equal. 0.142. And I get 1, 4.1 times 10. Let's see. 1, 2, 3, 4, 5 times 10 to the 5th meters per second. They wanted in meters per second? Yeah. Or I could write that as 1.41 times 10 to the 6th meters per second. Let's see which way this site likes the answer. I'm assuming they said 3 sig figs again. Yep. So I'm going to put 1.41 E. See if it takes E to the 6th. Oh, it didn't understand. Huh? Ah. Thank you. Yay. That's nice that they put that in there.